means they connected in a synchro way, so they can keep hold each other. So this is what I ask you in assignment, resource allocation graph. All right, you take the trade and the request to be sent or the resources as you know, the direct edges which they may hold, right? So this is important. I'm not sure if you have, how many of you have read this note? Did you go through the note? I have a product. Very well. So the request is an edge from, look here, we come from the trade to the resource. And also assigned edge is from the resource to the edge. Now, when we come to this figure here, you understand, right? The request from trade to the resource and assigned. Look here. What one is this? Which one is this? Trade to the resource. What is that? What this is doing? Is requesting, right? Now, right, correct. Now, what about this one? From here to here? Assigning. Okay. To your case, which you designed, which you thought, you can make like this one. I request this resource. You have to identify what resource is there. And then I assign resources assigned to this one. And then you make cycle manner like this way. Two processes are here. A request, this is what? Trade, request, and then assigned. Right? This is also assigned. Okay, it is assigned. This is assigned two ways. And this one is requesting. This one is assigned. All right, is assigned. So this is resource allocation graph. Okay, so this is what we mentioned here. The same case here, you can understand, right? What can you please read out T3? What T3 is doing? What T3 is doing here? Okay, from where? R2, right? And what happened to it? Is assigned the resources to from where? R3, right? Right here. R3 assigned. And then T3 is requesting R2, resource 2. Okay. Now, can you please read out T2? What is T2? You can read out T2. What scenario are there? You can read out this resource allocation. T2, thread 2. In one. T2, please. R2 assigned resources to R1 assigned resources to T2 request resource R3. Assigned and request. If it comes to you, you are assigned. If it goes from you, you are requested. Okay, you send a friend request. Do you know on Facebook? You send a friend request, right? If you send, then we will accept it. Now, if you look, for example, in Instagram, you may only have the followers, but you don't follow anyone. Correct? Why? Because somebody has sent a request, you accept it. But you didn't request. You may request but not accepted, right? So this is the same case here, right? This is the same case. What about this one? What about, can you please read out T1? Yes, T1. Okay. Excellent. Correct. Okay. All right. So this is it. Okay. Now we look to the basic factor facts which can cause a deadlock, right? Now, this is important as well. If graph contains no circle, no deadlock. If there is no circle, no deadlock. Look here, for example, this one forms the circle, right? It forms the circle, right? It forms the circle here. And here it says the first fact to understand, if the graph contains no circle, no deadlock. And also, if graph contains a circle, if only one instance per source, per resource type, then it's a deadlock. If several instances per resources type, possibility of deadlock. All right, so this is the basic one. Now we look to the method of handling deadlock. What are the method of handling deadlock? This is important. If you want to handle a deadlock, you need to ensure that these things can happen. You have to measure deadlock detection and also deadlock avoidance. I mentioned in the previous class, you can't prevent without letting it happen and see how you can prevent it, right? So here, allow the system to enter the deadlock state and then recover. That's the concept which was mentioned here. So you let it go into deadlock state, and then you can apply the recover. Or ignore the problem and pretend the deadlock never occur in the system. So these are the concepts which you can go on and read it. This is a method for handling, right? Prevention and avoidance. Or allow it to happen and then you recover, or you ignore all the problem and then you can see what will happen to the deadlock. Now, deadlock prevention. So in deadlock prevention, what you need to do, you need to avoid the mutual execution, hold and wait, right? These are the deadlock prevention. So not required for shareable resources, must guarantee that whenever a thread requests a resource, it does not hold any other resource. These are the method of preventing. Now, as we look to this method, you think and apply based on your cases. Okay, based on your cases. Can this be applicable? How can you prevent it? All right, how can you prevent it? Another one, no preemption, because we saw there are 4 types of characteristics of deadlock: mutual execution, and the previous one, hold and wait, no preemption, and the circular wait as well. So these are the way we can prevent a deadlock to happen. Okay, this is the way we can avoid a deadlock to happen. All right, let's look one more important topic as well. And I mentioned once again, please, you will meet this deadlock in many areas, right? It's important, either in exams, in quizzes, in interview. They may ask if you say that you know about operating system. Let's look to the following. The topic on synchronization. What is